So, if you remember in the last video, we established that if we had n objects, the number of ways of arranging those n objects without any kind of conditions whatsoever was just n factorial. So let's say, for example, we had 10 objects. We had 10 objects. The number of ways of arranging those 10 objects was 10 factorial. Okay. If we had 4 objects, the number of ways of arranging those objects was just 4 factorial. And this was just equal to 4 times 3 times 2 times 1. So in other words, we just take 1 off of the number each time and we just multiply them all together. So now let's suppose we have a group of objects like this. So remember, my group of objects is just cubes. Let's suppose I have my group of cubes that look like this. Okay, I've still got 5 cubes. I've still got 1, 2, 3, 4, 5 cubes. I've still got 5 cubes. Okay, but 2 of them are identical. So I've got 2 identical green cubes now. So how many ways are there of arranging those 5 cubes? Well, you're happy then that I've still got 5 cubes. So the number of arrangements that I could have is still 5 factorial. Okay, we've still got 5 times 4 times 3 times 2 times 1. That's still the number of arrangements that I can have. So let's say, for example, I choose this arrangement like this. So I put the green one first, then I put the orange one, then I put the blue one, then I put the yellow one, and then I put the green one last. Okay, so let's just take a snapshot of that. Okay, so I come along with my camera, take a snapshot of it, it's a flash, okay, and I just record that as a photograph. So here's my photograph up here, I've pinned it up on the wall. Now, let's suppose I just swap these 2 cubes over. So I put this green cube here, and I put this green cube here, okay. Now, so you're happy then, I've just swapped these 2 cubes around. Now compare that to the arrangement I had just a minute ago. So here's my picture, okay, compare this arrangement to that. There's no difference, is there? If you hadn't have known, if you hadn't have seen me just swap those 2 cubes over, you would say those 2 things are exactly the same arrangement. Okay, so by having 2 identical cubes in there, we're going to have identical arrangements. We've got identical objects, so therefore we're going to have identical arrangements. So in other words, we've overcounted. We've overcounted in this 5 factorial. We haven't got 5 factorial arrangements at all. We've overcounted. We've got too many because these arrangements are the same. So we're going to have identical arrangements in there. Well, how many identical arrangements are we going to have? And then that's fine. You know, then we can just remove from this 5 factorial the identical arrangements. So how many identical arrangements are we going to have? Well, how many identical cubes we've got? We've got 2 identical cubes. Okay, we've got 2 identical cubes. So how many ways are there of arranging those 2 cubes? How many ways are there of arranging these 2 cubes? Let's move these out of the way a minute then. So how many ways are there of arranging these 2 cubes? Well, there's going to be 2 factorial. Yeah, we've got 2 objects. How many ways are there of arranging them? There's 2 ways. So we can either have that or we can have that. We can just swap them over. So there's going to be 2 factorial ways that we can have of arranging these 2 identical objects. There's 2 factorial ways of arranging these 2 identical objects. So all we've got to do then is we've just got to remove these 2 factorial ways of arranging these 2 objects from my 5 factorial. Because remember, my 5 factorial, I've overcounted. I just need to remove the number of overcounting, you know, the number of identical arrangements. How many identical arrangements have I got? I've got 2 factorial of them. So all I'm going to have to do, remember what my 5 factorial is all about, it's just 5 times 4 times 3 times 2 times 1, okay? I'm just multiplying each time, okay? So in order to remove stuff from things that I'm multiplying, are you happy? I'm just going to use the opposite operation. So in other words, I'm just going to divide. Okay, so if I divide by 2 factorial, remember 2 factorial is just 2 times 1, okay, then all I do is I just end up cancelling that off. So what do I end up with? Well, I end up with, in this case, 5 times 4 times 3 times 2 times 1. So, in other words, in general terms, so my general question then is, how many ways are there of arranging n objects when a are identical? Well, I'll still have n factorial, but then I need to remove the number of objects that I've overcounted by. The number of objects I've overcounted by is just a factorial. Incidentally, let's suppose I have still my 5 cubes. So let's suppose I still have my 5 cubes, but this time I've got more identical objects. So I've not just got identical green cubes, okay, but I've also got identical orange cubes. And actually, let's say, for example, I've got 3 identical orange cubes. So actually, let's make this yellow cube orange. So I've made this yellow cube orange, okay? So I've got now 3 identical orange cubes and 2 identical green cubes, okay? Just to illustrate the example, I'm sure you can see what's happening. So how many ways? I've got 5 objects still, okay? So how many ways are there arranging just those 5 objects as if they were just ordinary distinct objects? Well, there's going to be 5 factorial ways, okay? But then I need to remove the number of objects that I've overcounted by the number of identical arrangements. Well, I'll have 2 factorial identical arrangements from these 2 green cubes, okay? But I'll then also have 3 factorial identical arrangements from these 3 orange cubes. So I'm just going to have to divide by another 3 factorial. By the way, maybe I should just write that out as well. So maybe if I just divide by 3 factorial, well, this is the same as 5 factorial over 2 factorial. When I divide by 3 factorial, then all I just do is I just flip this. Well, 3 factorial is the same as 3 over 1, right? So if I just flip this over, let's do a flip prickle, 1 over 3 factorial, and I change this to a times, just times the 2 things together. So that's how I get my 3 factorial on the bottom as well. All right, so I can actually have as many identical objects. So let's say, for example, if I had more identical objects, not that you can have any more identical objects out of 5, but yeah, all I just do is I just divide each time by the number of ways of arranging those identical objects. Easy.